Okay, hello. How's it going? So today I'm going to show you how I basically cloned Scaffold ETH and used it to build a really rather straightforward app. Scaffold ETH gave me a lot of like tools, like easy to use tools to do so, and I could do it very quickly. So I just want to show what I built, and I want to show you kind of like how I did it, and yeah, I'll show you the final app as well. So yeah, let's jump right in. Let's actually, I'll start with the code. So yeah, welcome. All right, let's take a look at the code. So we also got Cool Cat with us today on the other side of the screen there. But if you go to Scaffold ETH on GitHub, you're gonna find you're gonna find this code base, and they have really good documentation on how to get started. So you just need to clone it, you need to yarn install and start the chain and so on, and then deploy. So if you do all that, you're like, this app will launch on your local host, and you can interact with it. And they even have basically ways that you can use search to deploy it. So it's actually really nice. This is also part of this thing they run called speed run Ethereum. So if you have different quests and challenges that you can complete, and it on the back end it uses Scaffold ETH, so you can do a simple NFT example. You can do a decentralized staking app and whatnot, right? And just build it with Scaffold ETH, and you can get kind of familiar with that. So yeah, so that's pretty cool. So Scaffold ETH also uses this ant design, as it's called, ant.design, and it has different. It's like a React UI library, so you can you can go through the design, the docs, and it has certain components like layout and so on, mentions and select and so on. I really like this a lot. It's a very nice library. It's very clear. Um, in some cases, I wish it had a little bit more features, but in general, it's extremely nicely done, and like very comprehensive at the base level, so to speak. It has a lot of things, so that was super helpful. And yeah, and so with those things, what I did was clone it. I cloned Scaffold ETH into this directory, and you'll notice a few things. So one is when you go into packages, you'll have Hardhat, so that's where your contract lives, and then React app, and that's your front end side of things. I created this additional folder called IPFS image collection. That's because this app, and I'll explain to you in a second what it is just it's about an ERC1155 NFT. Um, kind of base token. So I needed to publish some images to IPFS that I could then use in the NFT. All right. So what is this app? So we're gonna build an ERC1155 token contract, and we're also gonna build a forging contract. So basically, let me show you the game, because I might as well. In fact, you know what? Let's do this. Okay, so just one second. So it's basically going to be leveraging, as mentioned, this new very gas efficient, kind of NFT format. I'm saying NFT can be used for other things too than NFTs. Um, but basically, you can have different multiple tokens registered with the contract, and depending on how many you have, really, of each kind of each type, it's either an NFT, really, or it behaves like an ERC20. So let me just get the link here really quick. And yeah, one second here. All right. Okay, that is escaping me. There you go. I got it. Sorry about that. Okay, so this is how it looks. You see a modal pop up here that says, "Oh, wrong network. You're not connected to Polygon." Okay, and it'll switch you over to Polygon, and that's pretty cool. So yeah, so there you go. This is the app. So it has this like header. You can There's a link to the OpenSea where you can see the collection. I called it the forger chains, and you can see the various like elements. You know, so you have wood, and there's a little description what it is. And there's a shield that you can forge by combining base elements together. So that's the collection, and this is all on the back end represented by this ERC1155, and you can mint things. So you look at this, you can click mint this, and it'll connect you, and you know it'll say, oh, this is going to cost some money to mint. I'm going to reject that transaction, but the point is you can do that. You can swap elements. I can click carbon down here. I can trade for iron if I want. I can, once I have multiple elements, I can combine them and forge weaponry. So there'll be a button called forge down here when I do it, and I can burn existing weaponry, like just lose it basically. That's it. It's not, I mean, it's not that comprehensive of a game, but the point was more just to show how to do a front end, and then also how to, you know, like use the ERC1155 standard. Yeah, so I can disconnect again up here, and it'll basically show like this. So I don't know, I like the design. I found this background somewhere, and then, you know, to the right, well, I think I bought this background. And then to the right, there's this like connect button on the divider here, which is kind of cool. These are all like features in the ant design that you can, you know, choose. So anyway, so what are we gonna do? So we're gonna take a look at the code. So I'm gonna show you VS Code here. Cool. So again, that's what we're gonna build. So I started from Scaffold ETH. Like I literally just started from Scaffold ETH, what I just showed you, and I built that. What I just showed you there. So you can start, and the base Scaffold ETH is like pretty basic. It has this like contract information and so on, just to get you started quickly, which I really did enjoy. It was very easy to figure out. Well, very well put together. So okay, so what happened? So as mentioned, you have this hard hat that's what controls all your contracts, like Solidity code. React app is your front end. So let's just take a look at the Solidity code first. In here, there's some scripts to deploy, right? In fact, that's not done there. That's done through Yarn, and then through this script. So, you know, there's a script to deploy. So you can, you know, you got to deploy the token, you got to deploy the forging contract. But let's see what it is. So if we actually look at the Solidity file, the token is an ERC1155. I also made it burnable. I also gave it a supply, and I made it ownable. So the idea is that this token will handle all these like mintable objects that I just showed you, like the various raw elements like iron, carbon, and stuff like that, and the weaponry as well, the shield and whatnot. And it's ownable by the forging contract. The forging contract is what handles the logic. So if you know, take iron and carbon and you combine them, you know, you forge them into a weapon, which weapon comes out and so on. So that's what the forging logic kind of handles. But the token on the back end just kind of handles holding the various token IDs, right? So that's what the ERC1155 is that I can go in and mint token 0, but I can mint a lot of token 0s if I want. Now, you can also limit the supply and say there's only going to be 1 token 0, but you can also say there's going to be 10 to the 18 token 0s, right? So why would you want that? It's like in a game, if you have, you know, if you have one type of shield, but you have multiple of those types of shield, well, you know, it's kind of an NFT because like it's one type of shield, but multiple people hold that shield, right? There can also just be one thing entirely. So that's kind of what this is. I'm just going to go straight to this mint function. In fact, I'm going to zoom in a little bit. I think I'm going to do it here. Yeah. So, yeah. So here in the ERC1155, you're going to get this underscore mint function, which will mint to an address the specific token ID you want to mint and how many you want to mint. And then you can also send in some data that we're not going to do here. But that's it. Now, notice that, of course, I use all OpenZeppelin contracts. I also, there's a constructor where I just give it like the base URI of the NFT, and this is what I use the IPFS for. And yeah, you know, you need to override the burn batch just because I'm inheriting these contracts, and you can burn. Call super to burn. We'll just burn the token. What else is there? Yeah, you had to overwrite that as well. So it's a relatively simple. And then, as you can see here, iron is represented by token ID 0, carbon 1, wood 2, and there are other IDs in here that are not like listed here because we don't need to list it here, but that the forging knows about. Okay, but the point is this will hold IDs 0 through 6, and I'm only showing you the first 3 here. Cool. So the forging logic, that's a little bit more interesting. Notice how it imports the token. It stores the token locally because that's the token that'll be holding all these like raw materials and weapons and whatnot. And you can see here the rest of the tokens is shield, crossbow, arrow, sword. Arrow probably being more like a bolt because it's for the crossbow. And then we have a cooldown period. So if you click mint on one raw material, you gotta wait at least a minute to mint again. It's just a fun feature. And then we have an event as well, a forge event that happens. And this cooldown will kind of keep track of, for a particular user, when did the cooldown timer start and are you in a cooldown mode right now? So can you actually mint or no? The constructor takes in the token address, as you guys can see. So you need to deploy token first, then construct the forging with the token as input. And, then we have the mint. So let's look at it. So if we're minting any of the tokens in the range 0 to 2, we do need a cooldown. That's just the rule. That's because we're minting the raw material. As I showed you over here in token, 0 through 2 is the raw material, iron, carbon, wood. And the other stuff is, here. The other tokens are more like what you can forge, like the weaponry, okay? So if we are if we did mint a raw material, well, all right, let's just get the cooldown, the current cooldown state for the sender, which will be just defaulted to like 0 and false if, they haven't minted before. And then we're just going to check, hey, did the timer expire, by the way? We're going to say, are you in a cooldown, first of all? If you are, is the current timestamp greater than or equal to your cooldown timer? If it is, oh, well, then you're not in a cooldown anymore, actually. And if you're not, then, and notice how when we get the cooldown state, we're actually pulling it from storage. So when we make changes now, this will go into permanency. Alternatively, we could pull from memory here. The problem is then we would, all this would not be stored back into the state, all these changes we're doing. So we do need that. Now, okay, anyway, so continuing here, are you in cooldown? Well, I cannot mint, I'm in cooldown, so I'm gonna revert here. Okay, if I'm not in cooldown though, it's gonna continue here and it's gonna set a new cooldown timer, which is the current timestamp plus whatever the cooldown period is, which happens to be a minute. And then it's going to say in cooldown is true. It's going to flip that to true. And it's actually going to go ahead and mint it because, again, we're not in a cooldown. And notice that if it's any other thing it's minting, like the weaponry, there's no cooldown. Okay, that's it. That's the rule. There's a URI, base URI. That's just for the image collection for the front end. And anybody can get a balance off. So notice that the balance off is like, you need the address and the token ID. Notice that, again, it's not like an ERC1155 NFT where it's like owner of a particular ID, right? Here you can actually have like multiple owners of a particular ID. So you need to get a balance rather. So you need to provide the address and the ID. And you can also do it in a batch way. So basically you can say, I want to get the balance of certain IDs, but like across multiple accounts and multiple IDs at once, right? Because every time you call this will cost you some gas, right? 21,000 gas at least to call it, plus all the other things that'll happen in the contract. And we'll get into more of those details about gas usage later on in a later video. But the point is, you can do all this in one call and save some gas, right? So that's nice. All these batch methods, like balance of batch, burn, batch, and so on. That's a nice feature. Total supply, you can see what's the total supply global to all the users of a given token ID. And you can do this trade. Remember I told you can kind of click that carbon and trade it for iron? That's what this trade does. So it actually just, the way it's implemented is like it just burns whatever you put in and mints new ones. An alternative way to implement this is to kind of have like the contract hold a lot of tokens or something like max integer amount of tokens almost, and then like kind of trade back and forth. But it will create some like non-trivial like boundary conditions. So instead the way I did it was just, okay, we'll just burn whatever they come in with and mint new ones instead of like transfer them basically. Okay, cool. And the forging logic is where it's very interesting, right? So here basically, if you forge, you can forge up to 3 elements. You can take carbon, iron, and wood all together and forge it into a weapon. So if the length of the incoming token IDs is 3, well, then you're forging a sword. If not, well, there are certain combinations here. So if you come in with 0 and 1, you can mint token in ID number 3, that's a shield. 0 and 2, it's a 5. 1 and 2, it's a 4. Notice that it's not like this 5 is the sum of these two, it's just that this is what it is. Combination token ID 0 and 2, mints ID 5. It's just the rules of the game. The way I implemented this is like a little bit efficient, I guess, in a way that I just said, look, if the length is 3, I know immediately it always has to be a sword. There's no way, because by the way, they have to be unique. Okay, so like you can't do 0, 0, 1. It has to be 0, 1, 2 in this case, always. If it's not length 3, there can be 3 different combinations, but they all actually have different sums. So what I can do is just sum up the elements in this 2 element array, and then just like kind of, switch on that sum value, and that's it. And then I'm going to emit a forge event, and I'm going to burn the incoming IDs, and I'm going to mint a new one, which is going to be that weapon. So this is the token to mint here. Okay, cool. And then you can burn, you can just straight up burn, which is helpful again for that weaponry you can burn. And then, yeah, some helper functions like the sum. This is a way to implement a sum of an array, and then create a ones array. So it basically just, this was useful when we came in with multiple IDs that had to be burned, like right here. You had to burn a batch when you trade it. You can click and trade multiples. So like you can actually click like wood, iron, carbon. So all 3 clicked, and then I can do trade. Okay. Yeah. So that just means we just needed to burn each of those incoming tokens at once. So that's what this is about. Okay, cool. That's the logic. I did thorough testing of these. So like I hit 90 plus in coverage. I mean, I recommend going to 100%, but for other reasons, this is 90 plus for both of them. And so definitely feel free to take a look at the tests. It tests all the minting logic and the forging logic and everything in here. And yeah, it was fun to do. And then it has a coverage report, which in my last video on how to test, I didn't show you the HTML for the coverage report. So I want to do that now, just so you can see how it looks. Okay, so this is the coverage report for this. So this is just when you run the coverage, like npx hard hat coverage, you will get a coverage report under a coverage folder that will contain a coverage.html. You see right here. And then what's going to happen is you'll have the 2 different files. I mean, technically all the files you have. In this case, I only have 2 files under this contracts folder. So I have token.sol, which is actually fully covered. It's 100%. So you see in here, it would show things in red if it's not covered. We'll probably see that on the other contract. But this is actually 100% covered on all branches, functions, everything. Forging is not 100% covered. I did not check the balance of batch, and I did not check this singular burn. Now, I know that works from the front end, but obviously you would still need to write a test. So yeah, I could have done that. Not a big deal, to be honest. Yeah, I'm getting like 94% plus. Again, if this was a production code, 100% you'd need to get. Cool. So that's how that looks. What else? That was the Solidity part of this, and with the deployment script right here. So again, you need to deploy the token first. That's what's going on here. Wait for 5 confirmations. After that, you deploy the forging contract. That will take a constructor argument, so you need to pass that in. And it's the token's address. Okay. And then after that, notice that we're actually going to transfer the ownership from the token, or from us, sorry, the deployer, to the forging contract. So the forging contract has control over the token, and nobody else can kind of come in from the side and start minting and burning and so on. So that's on purpose. Great. The local chain ID is set to hard hat. Actually, we don't need that. We don't use that. Cool. That's it. That's the deployment. So now for the React app, that was interesting. That was actually a lot of work. I mean, it took me like 2 days to put this together, and it's not that trivial. I had to also just because I wanted to understand it. This is my first really serious Scaffold ETH app. I've done all the ETH speedrun, and they've been fantastic, but this was the first kind of full on, just from scratch, like development, into like a pretty serious app. I would say myself. I'm not a front end engineer, so I would say like it looked relatively good, all considered. Now the thing is, okay, so how do you do that? Like, what did I do? Let's just go through it. Notice how we're using the ant design in general. Okay, Scaffold ETH is natively like it comes shipped with that. So if you want new components and so on, go to that website I just showed you, the ant design website, and you can kind of see everything you can put into this code here with actual code examples. So it's very helpful. What else is happening here? Now notice I didn't fully clean it up, like just because I emphasize speed over like necessarily getting it super clean, everything. So like my point is just that there'll be some things in here that are not technically necessary. Again, if this was a production code, of course you'd have to clean it all up. But you can actually go in here and get your deployed contracts. Isn't that smart? You can say import deployed contracts from contracts hardhat contracts.json. So that's pretty cool. Like when you compile it, this JSON will be created with the APIs, and then it'll just fetch these. So now we can actually interact with the contracts we have. Pretty easy. And then also from helpers, we're going to get the Web3 modal setup. So this is how we're going to set up our connection to the Ethereum client through our provider. And we're also going to use the static JSON RPC, right, as like the provider RPC. So the Ethereum client has like an RPC API, right, that this is how you talk to the client, basically. So you find a node, and that will expose a JSON RPC interface for you, and you can talk to the client, right? And then in turn, the blockchain. Now, in our case, we're actually going to use, just like kind of, instead of connecting to a specific node and talking to the blockchain, there are very nice providers out there like Alchemy and Infura and so on, and Morales that will actually give you that connection. So you just need like a link to them, and they will provide you with access to the Ethereum client and the blockchain and so on, so you can run commands against it. Okay, we're going to use ethers as well, so not Web3. We're going to use ethers.js, which is really a very up and coming library. So Web3 modal, again, this is what will enable us to connect with our wallet, with our MetaMask wallet. We have certain networks defined. You can go under constants, and you can see all these networks that we can actually technically deploy to. Okay. And some console locking and so on. But as you can see here, we're using the static JSON RPC on that RPC URL from whatever network we want. So let's say we want to connect to Polygon, which is what we deployed to in this case. Well, just go under target network.rpc URL. Again, that's defined under constant. So you see here, RPC URL. Well, this is mainnet, but they each have them. They even point to the block explorer. Okay, so now we're connected through, I think in the case of Polygon, we're connected through polygonrpc.com, actually. That's what we're using. But you can use other things like Infura and whatnot. But anyway, that's what gives us the access, local provider here. Now we define a lockout. So if you want to lock out, there's just a function that locks you out from MetaMask. What else? There are some hooks that can show you how to get the gas price. We don't really use that. So that's an example of something we don't use. Here it's going to use our injected provider for MetaMask. What we mean by that is that MetaMask will kind of inject itself into the browser, and we're going to basically catch that here, and we're going to say use user providers and signer, right? And basically get the signer. We're going to pick out the signer from this. The provider and the signer, the way they're typically used is you can use just the provider to read from the blockchain, but not to write. Like you can't change state because you need some private key. You need to sign a transaction, send gas, all this stuff to do that. So that's what the signer is for. So generally it's just called provider and signer. Anyway, so what else? Now we're just going to get the address of the signer. What else is happening? We have our local chain ID, selected chain ID. Why do we need that? Well, we're actually going to switch. We're actually going to show that modal error if they're not on the right network. We're going to force them to be on Polygon. Okay, what else? There is a transactor object that we can use to make transactions. It's just an easy way to make transactions. And what else? We can get the contract configuration and load the contract so we can read from it. So I'm talking about our deployed contract, the forging and the token and stuff like that. That's what this is doing. And the write contracts will well, we're going to use that to write contracts with. Okay. What else? And I'm not saying this is like the best way to set things up. I'm just saying this is what I did to do it fairly quickly. And then there's a bunch of callbacks here that you can use. So, if the user changes the chain that they're on, well, right now we're just locking and saying, hey, someone changed the chain. But, you could put different logic in here, right? And same for like account change. If you change account or if you disconnect and so on, you can put different things in here. I didn't. It's just going to log it to the console. And then this is connecting. This is the connecting piece. So notice how it says, okay, great. Let's grab from the window Ethereum object. Let's grab Ethereum. So that is how Web3 is injected into the browser. You can get it from window.ethereum. And then, you're going to put together some data about where you want to be, the target network, right? We're going to prepare some data here because what we're going to do is, we're going to try to, request a chain change, right? Again, if they're not on, Polygon, we're going to say, hey, please do be on Polygon. So we're basically going to send the parameters and say, hey, if you're not on this chain ID, which again, that's from up here. So in our case, that's Polygon, then do switch chains. Okay, so that's what's happening here. That's the logic. And we're going to do an await. So the whole thing is an async await structure because it'll take some time to change. And then if something went wrong, it'll actually even add the Ethereum chain. Like if, so for some reason, if you can't make the switch, try to add it. And if that fails, well, then you can handle that add error, which I didn't hear, but you could do that. So we're at least assuming that they have this MetaMask up and running. Fine. Okay. So for the app itself, what we're going to do, notice at the bottom it says return, and then it has this entire like div class name app thing going on. That's like basically the entire app that it just returns right from here. So use all the variables I just covered above, and you can pass them on as state variables down here and props and all this stuff, right? This is just React. So you have a header. I have this like show flame thing inside the header. So if you go under components and you go under header, I picked up this flame in an SVG file somewhere online. Yeah, I thought it looked pretty cool. So it'll show in the top left once you connect your wallet. But yeah, I'm passing in like whether you want to show flame or not. So I'm getting that from the props, which is passed in from my app.js. Here, show flame. Okay, and then, it just shows the account information. So this account component, which again, you can find on the components right here, account, is what shows you that little, it shows a little piece of the address there when you actually connect and everything. So it's pretty cool. Go check out that component. And again, a modal will show if you're not on the right network. A modal, that's that kind of pop-up box. It'll show if you're not on the right network, and it'll prompt you to change. So look at this. Actually, that's down here. You're not connected to the Matic network. Click to switch the networks, and then that calls the connect function that we just covered above, which did that switch. And if it wasn't there in the MetaMask, it'll add it. So that's what is done there. And then finally, so again, this is just kind of like account settings and what else? And the modal to handle if you're not on the right network. Okay, once we've dealt with that, now comes the main piece. We could have different routes too. You could imagine the game had different tabs that you could click your players or whatever up there. But we just have one main page, one route here. And that's the home component. And we're going to pass in a lot of state to that home component. So if we go under components, in fact, that's under views, and we click home, then there you go. There it is. So we're going to import a bunch of stuff from React and Ant Design and whatnot. And there you go. We just, start basically rendering the front end. Now, this should certainly be broken into a lot of different components for brevity and legibility. But this was kind of just duct taped together. I am running up against time, but I'm going to show you in detail how I did this in a follow-up video, but just in part one here. So now we're at the main part here. Let me just go as far as I can here, as far as like time allows. So what is happening here? I want to show you again the front end so you can just see where each component is. So localhost 3000, no, that's another app that I am building. Where did that go? Sorry, 1 second here. Oh. Okay. Let me just go there really quick. Okay, there you go. So this is the one. I always forget this. It's the soggy hen to search the shell. That's the domain I got. So, yeah. Okay, let's take it one at a time here. So first of all, how did we do the background? Okay, the background is actually done out here. So if you go to app.jsx, I think we actually did that in the header. So if you go into the header, you can see that this is the flame. I'll show you how the flame looks in a second. And then down here, by the way, you can also see, I used a typography element from AntDesign, and this is the title. This is the OpenSea collection link that I clicked before. This is a button to my Twitter. Feel free to follow me, CryptoJesperK. And this is actually the divider that will show the connect option here, and then it puts all the props to children. Now, where's the background? Oh, you know what? The background is in the CSS file. I thought I'd explicitly put it there. So the CSS file, you need to go to, let's see, where's the CSS? It's under app.css. Okay, so go under source, app.css. So you see here, I just do background, no repeat, center, fixed, like basically make sure it covers the entire page, and go under images background 2. So where's images background 2? Well, that's here, background 2. There you go. Easy. Now you need, of course, a high resolution image for that. But that's pretty easy. That was just a CSS thing. Okay, what else do we have? The buttons I just showed you. I showed you this. I showed you this. That's what was in the header there. And the divider, and then it does the props.children. That's what I also showed you there. All right, I'll stop it here, but I'll do a follow-up video where we can basically go through, how to, like I'll kind of cover how I did the other things in the app. So thanks so much for watching this part 1, and I'll follow up with the part 2. If you have any questions, let me know. Thank you.